Okay, so when we started this chapter, right, we've talked about circumference. We talked, which is perimeter, length of a line, for example. We talked about area, right? And when we talk about area, we talk about, like, if, for example, we're talking about a circle. Area is all about the number of squares that fit inside of a two-dimensional figure, right? The other day, though, we moved to 3D figures, three-dimensional figures. And we talked a little bit about the parts of a 3D figure. Well, what we're doing today is we're going to talk about not just the parts, but we're going to talk about measuring those 3D figures. Okay, so you do that, and specifically the 3D figures we're talking about today are only prisms. What we're going to do is we're going to talk about volume of prisms. We do that by finding out what the volume is, and that's the way we measure. So, at least for today. So, our word is volume, everyone?
Volume.
So, here's what the book says volume is. It's the measure of space occupied by a solid region. The measure of space occupied by a solid region. Okay, kind of an interesting take on it. But here's what it kind of means. If you're talking about a 3D figure, it's the space inside. Now, if we talk about the space inside, let's take this wonderful class Kleenex box, for example. Okay, yes. Okay, and if we take this Kleenex box, the problem with this is we cannot use these squares to find out how much space is inside. You actually need a tool that is also three-dimensional. And so when you're talking about volume, you're talking about how many of these things, which are cubes, how many cubic units fit inside. And that's what volume is. We're finding basically, and they call it, right, how much, what is it, the space occupied by a solid region. Well, you talk about, when you talk about volume, you're talking about the number of cubes that occupy that space. Okay? So, with that said, I do want to show you guys something. I want to talk a little bit about how to find the volume of a figure. Okay, now, if we're looking at that, right? Just looking at the blue and green there, what kind of shape does that form? It forms a rectangle. And if we're talking about a rectangle, it's going to be a two-dimensional figure. We're going to be talking about base times height, or what you guys talked about, like even in elementary school, length times width. That's how you find the area of a rectangle. So if I'm plugging numbers in here, what would be the length of this rectangle? If we call this the length, it's 3. The width is 2. All right. By the way, these are centimeter cubes, so it'd be 3 centimeters by 2 centimeters. And so if we're talking about the area, we're going to have, of course, 6 square centimeters. Okay. Now, the difference between area and volume is this, especially when it comes to a prism. It's taking that and realizing that there's no light there and it's kind of dark, but you could see how many layers are there? There's 2 layers. So there's not 6. How many are there? There's 12. Right? You have 2 layers. What that is it's the third dimension. We have the length, we have the width, but there's a third dimension there. And we can think of it as how many layers there are. Okay? So when you're talking about volume, okay, someone realized, well, you can actually find the volume of any prism by taking the area of the base, this top right here, because it's a rectangular prism, it's a rectangle, you could take the area of the base, which is what we did here. Now what they did is they said, well, we need to, not every base is going to be a rectangle. So here's what they did. They gave it a letter. It's a capital letter. It's a B. That represents the area of whatever base. So if it's a triangular prism, then the base is a triangle, right? If it's a cylinder, what would be the base? A circle. This right here means area of whatever the base is. And then what you do is basically bend over the camera and see the third dimension. And in this case, they call it the height, but it's not always height. It could be depth, it could be, thickness, or whatever you want to call it. But the H comes from height, but it stands for the third dimension. Okay, how many layers it is. Okay, and this is going to be the formula you use for the volume of a prism. This formula is not specific to any prism. It's a generic formula for all prisms. Okay, so that's what we're going to be doing today. All right, so here is what I'd like you guys to do. Go ahead and you can go ahead and grab your book, grab your piece of paper if you haven't already done so, and flip over to page 583. 583. If you haven't already filled out your paper, right? Name, date, period on it. Now, this actually, I like showing this. This isn't in, it might be in your book, but I know the exact page. So here's what I showed, because we just talked about this with my Math 7 class. So this is kind of what we were just talking about, a little bit bigger though, right? You have your base, you find the area of it, and then of course there were two layers here, so you'd multiply by the third dimension. But more importantly, this gives you an idea of a triangular prism. You still have to find the area of your base. This time it would be a triangle. And then you, of course, multiply by the third dimension, which is the height of this triangular prism. Okay? So this just gives you an idea that it does change between rectangular and triangular prism, but that is kind of a visual of what we're going to see with a triangular prism today. All right? So, with that said, let's go ahead, and I want to look in your book at problem. Let's just start on page 583 at problem number 6. Okay? Now, this is just one that I'm going to do. All right? You don't have to do this. It's on your homework. I'll let you copy it down in just a bit. I just want you to put down your pencil and watch. Now, I'm not going to draw the exact the way they drew this is kind of interesting. I'm not going to draw the exact picture, all right, because it'd take too long with all of the little cubes shown. All right, but okay, you guys will get an idea. So we have that, and and I know it's exactly a cube because even though mine's a little longer, a little higher, but it's a 4 by 4 by 4. All of the dimensions are 4. Okay, so here's what you're going to do with all of your problems today. All right, or at least the start of this unit or this page, this lesson. Volume is found by finding the area of the base and multiplying by the height. Well, the base can be any of these. I'll go ahead and just count this as the base. I need to find the area of that. This is a rectangle, or in this case a square, right? It's length times width. I'll bring down h since it's our third dimension. Now, the length is 4, the width is 4, so that gives me 16. That is the area of the top. If you take a look in your book, right, there ends up being 16 little squares on the top. And again, as soon as I find my third dimension, it's here, it's like I said, it's like bringing the camera down and seeing the side view. There are 4 layers to this, and that's why we multiply 16 with 4. And of course we get 64. Now don't forget your units, of course, and here's the other thing to remember. it is cubic meters. Don't put square, because that means something completely different. 64 cubic meters. Okay? So I'm not going to let you ask questions yet, because I want to do one more with you, and then I'll let you ask questions. But for right now, you don't have to copy down. As a matter of fact, please do not copy that down, because it's going to take some of us a long time. Just go ahead, copy down the work there, and then we will move on to our next problem. Okay, here we go. Let's take a look at problem number 18. Problem 18. I don't know if that'll show up on the video or not. Hopefully not. All right, this is just the projector. Okay, here we go. Number 18. It's going to, of course, be a little more challenging, right? This is an advanced class. So if we take a look at 18, let's go ahead and read this really quick. Let's close read it. It says, Jill is a candle that is in the shape of the triangular prism as shown. Okay, so obviously you don't have to draw this, but I'll go ahead and... So a fancy triangular prism candle. 5 says that this dotted line here is 2.6 and this line right here is 3, and they're all in inches. So there we go. Then it says, and this is the word problem, it says she puts the candle in a rectangular box that measures 3 inches by 5 inches by 7 inches and places foam pieces around the candle. Find the volume of the foam pieces needed to fill the space between the candle and the box. So listen, I'm going to just make a quick sketching of this box. It's going to be kind of like the last problem we just did, but it gives you an idea. Okay, this candle here is going to go inside there, and they want to know, once we put it in there, how much space is left. Well, I'm already visualizing this. We need to find the volume of this. We need to find out how much space this takes up, which is the volume of that. And what do you think we'll have to do at the end? Subtract. We subtract, right? And find the difference in the two, and that's the extra space. All right? So, with this particular problem, here we go. Step 1, let's find the volume. As a matter of fact, let's find the volume for step 1 of our triangular prism. So here we go. Step 1 is write down the volume formula. Okay? Now, what I'm going to do with this is a triangular prism. So step 2 is I'm going to rewrite this being more specific. The base is right here. It's a triangle. It is 1/2 base times height. Please don't forget that part. So many people think volume, I'm going to take all the numbers I see and all multiply them all together. They have that idea. That is not the case. So be careful. The triangle is 1/2 base times height. Then I'm going to bring down this h just for my third dimension. Then what I'm going to do is I'm going to find the area to the base, just like we did with the rectangular prism. The area of the base is 1/2. The base of this triangle is actually right here. It's kind of on the top there, at least from our view. It's 3. The height is this little dotted line. It's 2.6, 2 6/10. Where I don't forget, I'll bring down my h again. Now, definitely calculator time. So 2.6 times 3 equals 7.8, and I'm going to split that in half by dividing by 2, and I get 3 9/10. Now, I'm going to do step 4, and that is I'm going to plug in my third dimension. Remember, it's like moving the camera down to see that the number of layers. And in this case, it's this right here. It's 5. Now, step 5 is I'm going to multiply these two and solve. 3.9 times 5 equals 19 and 5/10. Now, step 6, we'll call this step 6. Don't forget your units. I'm going to put a little star by step 6 because don't forget, it's cubic units. And in this particular problem, the units are labeled with, it's all in inches, so it's cubic inches. Okay? So, that is the volume of the triangular prism, which is our candle. Now, instead of going through all these 6 steps and get like to step 12, here's all I'm going to do. I'll put step 7. We're going to, on this particular problem, we're going to repeat the process, but with the rectangular prism. So here we go. Volume equals the area of the base times the height. Now, I need to go back and label this rectangular prism. It says is a 3 by 5 by 7. So, if this is my base here, the volume of a rectangle is length times width. So I plug in my numbers, a 3 and a 5, and bring down my h. That, of course, solving that, the area of that rectangle is 15. Then I'm plugging in my third dimension. In this case, it's 7. 15 times 7, I solve this, it's 105. And this is, of course, cubic inches. And then we can call this step 8. And guys, the main steps, of course, was step 1 through 6. That's the basis of this lesson. But step 8 in this particular problem would be, like you guys said earlier, we're going to subtract 105 minus 19 and 5/10. So 105 minus 19 and 5/10, and I get 85 and 5/10 cubic inches. And that's how much foam we need, or how much space we have to fill with foam. Okay, guys, questions on, it could be on this kind of problem. This is, I don't want to call it a challenge problem. We did it together, but it's a little more challenging than a basic volume kind of question. My number one concern is finding the volume of any kind of prism. John? So good question. If on a rectangular prism, to be honest with you, it doesn't really matter the size of the box on a rectangular prism. They didn't go into specifics about that because in the end you would have gotten the same no matter what. But if it does matter, especially on a triangular prism, they'll be more specific. Okay, so you won't have to worry about that. All right. Here's what I want. I just want to really quickly, I wanted to do this, but considering time, let's take a look at number 16. I just want to talk about it. It says, Josh and his mom are building the doghouse shown below. Find the volume of the doghouse. We have a rectangular prism. Ignore the door. Rectangular prism and a triangular prism. How is that different than what we just did? You add them. Okay. They're basically three-dimensional composite figures, meaning two separate prisms just put together. So you'll add them instead of subtract them. Okay. All right, here's what I want to look at, the last one. Let's take a look at 583, problem number 15. So here we go. It says, 15 says, find the height of a triangular prism with the base length of 10 yards, a base height of 20 yards, and a volume of 600 cubic yards. Now, with this particular one, you can draw it if you want, but you don't have to, and here's why. If I go ahead and do step 1, volume equals the area of the base times the height. Then here's what I'm going to do. Step 2. I am going to, it's a triangular prism, right? So I'm going to do the same as step 2 here. Volume is equal to 1/2 base times height of the triangle with the third dimension. Step 3. I'm going to plug the numbers into the equation, into the formula. So here's what it is. It says find the height of a triangular prism with the base length of 10 yards. Look at this. The base length means the base of the triangle. It's 10. The 1/2 is a constant, right? It remains there. Then it turns around and says a base height, meaning the base is a triangle, so the height of the triangle is 20 yards. But look what they say. The volume is 600. I'm plugging in 600 for the volume. Remember what it started off with. It wants us to find the height of the prism, which is the third dimension. Now, by now, right, this should be reviewed. It's been a little while, but solving this equation, step 4. So let's start by simplifying this side. 1/2 of 10 is 5, and what's 5 times 20? Yeah, 100. So that part was nice and easy for us. We simplified that right side. Now 100 times h, we divide both sides by 100. And what is our height of this prism? 6. And don't forget, I'll go ahead and put step 5 here, because none of you guys said it right now. 6 what? Ah! We're only talking about the height. 6 yards. Be careful. The 600 is the cubic yards, right? Because that's the volume. We're only talking about the length. We're only talking about this right here. We're only talking about 6 yards of height. So be careful. Don't put cubic. You'll be wrong, because that says how many cubes. It's just the length of that height. All right. Volume of prisms.